Okay, so we're in section 8.4, properties of rhombuses and rectangles and squares. Let's first define a rhombus. A rhombus has a pretty simple definition. It's just a parallelogram with four congruent sides. Parallelogram. Okay, that's it. We just need to have opposite parallel sides, and they need to be congruent. All four of them, and we have a rhombus. A square is a special type of parallelogram. It's a parallelogram that has four congruent sides, and it also has to have four right angles. Okay, so we've got a parallelogram with four congruent sides and four right angles. So if we were to draw this, you guys have all seen a square before, but we've got parallelogram with right angles. In fact, we don't need to put the parallel symbols in, because if it's got four right angles, then we know that we have a parallelogram. The question, is it a rhombus? Yeah, it is, because all the sides are the same, right? So the question to this is, yes, it is a rhombus. And let's actually officially define a rectangle. A rectangle is a parallelogram, again, with four right angles. Okay, and that's it. We don't have to have sides equal or anything like that. It's just a parallelogram with four right angles. And like the square, all I need to do is write in these four angles, and I know that I've got a rectangle. So this would be like rectangle A, B, C, D. The question is it a square? I'll leave that for you to answer, so kind of think about that. Is a rectangle a square, or could it ever be a square? Okay, theorem 8.11, 8.11, a parallelogram is a rhombus if and only if its diagonals are perpendicular. So if I've got a parallelogram, and I don't know that it's a rhombus, okay, so I kind of draw this thing on here, and I don't know that it's a rhombus, but I know that I've got a parallelogram if and only if its diagonals are perpendicular. I know that I have a rhombus. So if I draw in the diagonals here, and I get that they form a right angle, then I know that I've got a rhombus. Okay, so if we label this A, B, C, D, A, B, C, D is a rhombus if, is a rhombus if and only if AC is perpendicular to DB. Sorry, I'm not sure why the pen's glitching, but AC is perpendicular to DB. That's what that last thing says there. So basically, you just need to know that the diagonals here are perpendicular. Okay, so this theorem says that if I start with this picture right here, a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So I've got my rhombus, or I've got a parallelogram here. Right, so I know that I've got a parallelogram. Okay, and then I'm going to draw my diagonals, DB and AC. And what this theorem says is that I know I've got a rhombus if these angles are bisected. Okay, so if these angles are bisected, like this, okay, and then we might have 2, 3, 1, 2, 3. They don't look congruent if I had a good rhombus here. They would be. But it just says a parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. And in fact, I think you'll learn that the opposite pieces are also congruent to each other. Okay, so that's all that says. Okay, this last theorem here is a parallelogram is a rectangle if and only if its diagonals are congruent. So I'm going to draw a rectangle in here. Remember, a rectangle is just a quadrilateral with 4 right angles, a parallelogram with 4 right angles. Okay, and then I'm going to draw on the diagonals. Okay, we can call this maybe A, B, C, D. Let's say that they intersect at point M here, and that this is congruent here, 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 and here. That's what the theorem says, is that if these things, if we have a parallelogram, it's a rectangle, if and only if its diagonals are congruent. Let's actually write this out. A, B, C, D is a rectangle if and only if, IFF, that means if and only if, AC is congruent to DB. Okay? And that's all that one says. And then we can also write one more thing here that you probably want to put below it. This also means that AM equals DM, which equals BM, which equals CM. Okay, so all these pieces right here are congruent. All those little pieces, it bisects each other, right, because it's a parallelogram. And that's the theorems. Let's move on to some examples. Okay, let's do this example here with the square. So I want to find x and y, and I'm given a square, so we would know that we've got a bunch of right angles in there. If it's a square, I know that all the sides are equal, so I know that CD equals AD, which equals BA, which equals AC. So if I want to find x, I can simply set these things equal to each other. 5x minus 4 equals 3x. Subtract 5x, subtract 5x. I get negative 4 equals negative 2x. And when I divide by negative 2, I get that x equals 2. Okay? Now I can do the same with y, right? So 2y plus 4 equals 5y plus 1. Those things are equal. And so I can do the same thing there. Why don't you try that one, and then I'll check to make sure you did it right tomorrow in class. So once again, equal sides of the square. So we're just going to set this stuff equal to each other. Okay, let's move down to the rectangle problem there. So in this one, if I've got a rectangle, I know that I've got parallel sides, right? So this is a parallelogram, and I'm going to highlight these lines here, BC, AC, and AD. Okay? Now I want you to notice that these are parallel lines, and that this line AC is a transversal. Okay? So that means that 33 and x are alternate interior angles. So x is congruent to 33, so x equals 33 degrees. Okay? We also know, well, we can figure this out in a number of ways, but we also know that if this is a rectangle, then all these little parts of the diagonal here, these are all congruent to each other, right? Learn that up above. So if that's true, then this triangle right here that I'm going to highlight in red, okay, is an isosceles triangle, which means that this angle D right here must be 33 degrees. Now that doesn't help us immediately, but if this angle is 33, this angle is 33, then this angle Z up here must be 180 minus 33 minus 33. So Z equals 180 minus 33 minus 33, and Z equals, was it 114? 114 degrees. Okay, so check my math on that. I'm pretty sure it's 114. And then I want you to go ahead and try and find y. Remember, the important thing for finding y is that all these angles are right angles. You know, that I'm kind of highlighting here. So go ahead and try and find y there. I know this got kind of messy. And we'll talk a little bit more about this one tomorrow in class. But try and find y. Let's move on to the next example. Okay, in this one, I want to find x. And remember, I've got a special shape here. It's a rhombus. And so what I know about a rhombus is that it has to be a parallelogram. Okay, so those sides are parallel and these sides are parallel. If it's a parallelogram, then I know angle A plus B, those are supplementary. Okay, so these are supplementary. Supplementary angles, which means they add up to 180 degrees. So A plus B equals 180, so let's go 2x minus 1 plus 127 equals 180. Alright, and now I want to solve this, so I'm going to combine like terms, 2x, and then this is going to be plus 126 equals 180, and I'm sure you guys can finish out the math here. But minus 126 from both sides. Okay, and I get down to 2x equals, let's see, 54. And if you divide by 2, you get down to x equals 27. Very, very important. Pay very close attention to these angles. You know, when you're working with these problems, these angles are clearly not congruent, right? This is an acute angle down here, angle A, and angle B is an obtuse angle. So you have to be able to see that, you know, I mean, even if I don't know my rule, those are clearly not equal angles. So we've got to find some other relationship between B and A, and that is, obviously now you know, it's that they're supplementary. So be careful when you analyze pictures, what you know and what you don't know, and kind of use reasoning. Don't just try and apply a formula to every problem. Okay, this last example is kind of a neat one. You want to find the length of AC, so what we're going for here is AC. I want you to do this one on your own, but remember this is a very important rule, that this segment is congruent to this segment, which is congruent to this segment, which is congruent to this segment. Okay, so that is incredibly important to do this. Sorry, I'm not sure why that cut out, but to do this problem, that all those segments are congruent. So use that to first find y, and then find the length of AC. We'll check it in class and make sure you're on the right track. So that's it for section 8.4. Have a great day, and we'll see you tomorrow.